In this problem, we will work with this third-degree polynomial to answer some questions about the function using Excel. The problem tells us the equation of this f of x function. First question asks what type of function this is. I notice that it has the form ax to the third minus bx squared plus cx plus d. That is a third-degree polynomial. More commonly, we call these cubic functions. So we select cubic. It asks us to identify the y-intercept. The y-intercept is the point on a graph that has an x value of 0. Notice if you let x be 0 in this function, the first term, the second term, and the third term would all become 0, leaving only f of 0 equals 17.57349. It's always this constant term that is the y-intercept value. So the y-intercept is 0, 17.57349. It says to use Solver on Excel to find the x-intercepts of this function, and it gives you a hint that you should create your table using x values from -10 up to +10. It also notes to you that there are 3 solutions. So I'm going to go over to Excel. In Excel, I have already created the input-output table spanning from x is -10 up to positive x is 10. And I've put the y values in using an equation. I wrote the function in Excel. Y value is equal to this cubic function where it pulls the x values from column A. I'm going to go ahead and highlight that and insert a smooth line graph. There it is. So this indeed does look like a cubic function. We see it's increasing concave down up until this little local maximum point, and then it's decreasing concave down until an inflection point around here, and then it's decreasing concave up until this local minimum point, and then it's increasing concave up after. It asked us in the problem to identify the x-intercepts, and it said there were 3 of them. I see there's one here. It looks like it's about x is -3 approximately. One here at about x is 1, and one here at about maybe x is 6. All right, so I have a sense of where they are on the graph. I'm going to now go to my table, and I'm going to use Solver 3 times. Let's first find this one that is between -5 and 0. It looks to me like somewhere between rows 5 and row 6, the y value changed from being negative to y value being positive. See, the y value is -54, then the y value is 22. So somewhere in between, the y value became 0. I'm going to put my cursor in cell B6, which is near that point where the y value is 0. I go to Data, Solver. I want the set objective cell to be the cell closest to where the y is 0, which is cell B6. I want it to be a value of 0 by changing the x value cell, so cell A6. I am going to uncheck the box that says make unconstrained variables non-negative. I don't want Excel to force the answer to be positive. It's okay for my answer to be negative. In fact, I expect the x value to be negative. And then I hit solve. It changes the x value cell to -2.91. Remember that this 2.45161 -6 is actually scientific notation. It means the number 0.00000245161. But that is really just 0. Excel is giving us an approximated value. That's approximately 0. When x is -2.91, the y value is 0. So this is one of the x-intercepts. So I'll enter that as one of the answers. Next, noticing on the graph that there seems to be an x-intercept at around x is 1, I look in my table at approximately that area. And I see, yes, indeed, the y values change from positive to y being negative, somewhere between x is 0 and x is 2. So I'm going to put my cursor about here, which is near the point where the y value is 0. And again, I go to Data, Solver. This time I set my objective cell to being cell B9, changing to a value of 0 by changing the x value cell A9. I hit Solve, and it says that the x value is 0.99 to make a y value of 0. Again, this number in Excel, negative 6.50808E negative 6, really means negative 0.000000. I think I got them right there. That's a lot of zeros. 0808. And that is really just 0. It's just Excel's rounding. So here is another x-intercept. When x is 0.99, the y value is 0. Looks like my next x-intercept is at about 6 or 7. And so I see, yes, in the table, when x is 6, the y value is negative. When x is 8, the y value is positive. So somewhere in between x is 6 and x is 8, we're going to get a y value equal to 0. I'm going to put my cursor in cell B12, and I'm going to use Solver. So Data, Solver, set objective cell this time is cell B12, changing to a value of 0 by changing cell A12. Hit Solve. And again, we get an x-intercept. Again, instead of giving exactly 0, it returns a y value that is approximately 0. It's 3.01 times 10 to the negative 7th, which is really just about 0. So the last x-intercept occurs at x equals 6.1. I put that last answer in, submit the question, and it gives me all green check marks.